The Inyo Craters are a volcanic chain of craters, domes and lava flows in Mono County, eastern California, United States. The chain stretches 25 miles from the northwest shore of Mono Lake to the south of Mammoth Mountain. The Mono Lake volcanic field forms the northernmost part of the chain and consists of two volcanic islands in the lake and one cinder cone volcano on its northwest shore. Most of the Mono Craters, which make up the bulk of the northern part of the Inyo chain, are phreatic volcanoes that have since been either plugged or overtopped by rhyolite domes and lava flows. The Inyo Craters form much of the southern part of the chain and consist of phreatic explosion pits and rhyolitic lava flows and domes. The southernmost part of the chain consists of fumaroles and explosion pits on Mammoth Mountain and a set of cinder cones south of the mountain. The latter are called the red cones. Eruptions along the narrow fissure system under the chain began in the west moat of Long Valley Caldera 400,000 to 60,000 years ago. Mammoth Mountain was formed during this period. Multiple eruptions from 40,000 to 600 years ago created the Mono Craters, and eruptions 5,000 to 500 years ago formed the Inyo Craters. Lava flows 5,000 years ago built the red cones, and explosion pits on Mammoth Mountain were excavated in the last 1,000 years. Uplift of Poe Island in Mono Lake about 250 years ago is the most recent activity. These eruptions most likely originated from small magma bodies rather than from a single, large magma chamber like the one that produced the massive Long Valley Caldera eruption 760,000 years ago. During the past 3,000 years, eruptions have occurred every 250 to 700 years. In 1980, a series of earthquakes and uplift within and south of Long Valley Caldera indicated renewed activity in the area. The region has been used by humans for centuries. Obsidian was collected by Mono Paiutes for making sharp tools and arrow points. Glassy rock continues to be removed in modern times for use as commercial scour and yard decoration. Mono mills process timber felled on or near the volcanoes for the nearby boomtown Bodie in the late 19th to early 20th centuries. Water diversions into the Los Angeles aqueduct system from the natural outlets in Mono Lake started in 1941 after a water tunnel was cut under the Mono Craters. Mono Lake volcanic field and a large part of the Mono Craters gained some protection under Mono Basin National Forest Scenic Area in 1984. Resource use along all of the chain is managed by the United States Forest Service as part of Inyo National Forest. Various activities are possible along the chain, including hiking, bird watching, canoeing, skiing, and mountain biking. Geography and description. Setting. The Inyo Craters form a volcanic chain in eastern California that sit along a narrow, north-south trending fissure system that extends from the north shore of Mono Lake, through the western moat of Long Valley Caldera, and south of Mammoth Mountain. The chain is located in Inyo National Forest and Mono County, California, and the nearest incorporated community is Mammoth Lakes, California. The Mono Craters are located in Mono Basin, itself part of the Great Basin. Mono Craters. The Mono Craters are a 10.5-mile chain of at least 27 volcanic domes, 3 large glass flows called coulees, and various explosion pits and other associated volcanic features. The domes of the chain lie on a roughly north-south trending arc that is concave to the west and located south of Mono Lake. The highest of the Mono Craters domes is Crater Mountain, which rises 2,400 feet above Pumice Valley to the west. Associated volcanic features are located in Mono Lake and on its north shore. The coulees cluster north and south of the overlapping chain of domes. Craters exist at the top of most domes and on flat land south of them. Inyo Craters. The two southernmost Inyo craters are open pits in a forested area that are about 600 feet across and 100 to 200 feet deep, each with small ponds covering the floors. A quarter-mile north of these is another Inyo Craters explosion pit on top of Deer Mountain. Farther north of these craters are 5 lava domes, including Dead Man Creek Dome, Glass Creek Dome, Obsidian Dome, and Wilson Butte. These domes are composed of gray rhyolite, frothy pumice, and black obsidian. The Inyo Craters volcanic chain extends into Long Valley Caldera but is not related to the Caldera's volcanism. Reedy cones south of the Inyo Craters proper are other features related to the dike system responsible for creating the craters, volcanoes and lava flows. These include a north-south trend of fault scarps up to 20 feet high and pull apart cracks or fissures in the earth. These fissures are not technically faults because little or no vertical or horizontal movement has occurred along them. Most notable among these is Earthquake Fault, a fissure up to 10 feet wide that cuts 60 to 70 feet into glassy rhyolite lava flows. The fissure was formed by stretching induced by the intrusion of the Inyo dike. Stairs to the bottom of the fissure were removed after being damaged by earthquakes in 1980. Several Inyo-related explosion pits are on Mammoth Mountain. The red cones, south of Mammoth Mountain, are basaltic cinder cones and are the southernmost part of the Inyo Craters volcanic chain. Climate and ecology. The Inyo Craters are in the Central Basin and Range ecoregion of the North American desert. The desert environment of Mono Basin receives about 14 inches of precipitation a year. Annual precipitation around Mammoth Lakes, which is close to the Inyo Craters, is about 23 inches. Moisture travels over the Sierra Crest from the Pacific Ocean through the San Joaquin Gap. Temperatures in Mono Basin range from average winter lows of 20 to 28 degrees Fahrenheit to average summer highs of 75 to 84 degrees Fahrenheit. Temperatures near the Inyo Craters and Mammoth Lakes area range from winter average lows of 16 to 21 degrees Fahrenheit to summer average highs of 70 to 78 degrees Fahrenheit. Most of the surface of the Inyo Craters is barren but its slopes are covered by Jeffrey pine forest and partial greenery. Pumice Valley, directly to the west, is covered by sagebrush scrubland. The soil consists primarily of deep pumice, which does not hold water well. Mycorrhizal fungi in the soil invade the roots of Jeffrey pine trees in a symbiotic relationship that helps the pine absorb water and provides nutrients to the fungi. Jeffrey pine forests also surround the Inyo Craters and Mammoth Mountain. Mule deer, coyotes, black bears, yellow-bellied marmots, raccoons and mountain lions all have ranges that are coincident with forests that cover parts of the Inyo Craters. Typical evolution. Panum crater is the northernmost volcano in the sequence and is a good example of both a tuff ring and a rhyolite dome. Its structure is twofold, an outer tuff ring and an inner plug, or dome of rhyolite, pumice and obsidian created from lavas. In this case, heat from the magma feeding Panum flashed groundwater to steam to create the tuff ring before lava reached the surface. Other monocraters also were formed in this manner, but the plug domes grew larger than the tuff ring craters. The domes have steep sides and are flanked by slopes of scree consisting of large angular and glass-rich rocks. Devil's Punchbowl, located south of the main dome complex, stopped forming at an earlier stage of development. It is a 1,200-foot wide and 140-foot deep explosion pit with a much smaller glass dome on its floor. The large north and south coulee and the smaller northwest coulee consist of obsidian-rich rhyolite. They were formed from slow-moving lava that had a thin and brittle crust. Once the flow stopped, it formed steep-sided tongues of sharp and angular rock that are typically 200 to 300 feet thick and have scree piles along the base. South Coulee is 2.25 miles long, 0.75 miles wide, and has a volume of 0.1 cubic miles, making it the largest monocrater Coulee in volume. South Coulee originates from the crest of the monodomes, about 3 miles from the southern end, flows down its east and west flanks and terminates at its foot. North Coulee is nearly as large, flows mostly to the east and terminates in a divided pair of lobes. Northwest Coulee is located northwest of North Coulee and was intruded by Upper Dome after the Coulee solidified. Permanent pockets of ice from snow melt have been found 75 to 147 feet inside the coulees and domes. Geology Background. The Inyo chain of craters lies in east-central California, roughly parallel to the eastern escarpment of the Sierra Nevada mountain range. Volcanism and seismic activity in eastern California are a result of two major geologic processes: northwest movement of the Pacific Plate with respect to the North American Plate along the San Andreas Fault system near the coast, and east-west extension of the crust that formed the Basin and Range Province. In the Long Valley region, where the craters are located, Basin and Range extension encroaches onto the thick and stable crust of the Sierra Nevada. Basement rock under the Inyo chain consists of the same granitic and metamorphic rock that make up the Sierra Nevada. Above the layer are basaltic grading to rhyolitic volcanic rocks that are 3.5 million to less than 760,000 years old. Volcanism occurred north of the chain, in the Bodie Hills, as far back as 28 million years. Nearly all the rock east of the Sierra Nevada in the Mono Basin area is volcanic in origin. Volcanoes erupted from 3.6 to 2.3 million years ago near what is now Long Valley. Rhyolitic eruptions occurred in and around Glass Mountain in the same area from 2.1 to 0.8 million years ago. Volcanic ash from the massive eruption of Long Valley Caldera some 760,000 years ago is preserved in the thick bishop tuff that covers much of the region. Eruptions of basalt and andesite 400,000 to 60,000 years ago in the west moat of Long Valley Caldera were the first activity associated with the Inyo Craters system. Eruptions around 300,000 years ago filled the west moat with 800 feet of basaltic lava. Basaltic and andesitic eruptive activity then moved to Mono Basin and lasted from 40,000 to 13,000 years ago. Seismic data indicate that a magma chamber with an estimated volume of 48 to 144 cubic miles exists 5.0 to 6.2 miles directly below the Mono craters. About 660 feet of subsidence has occurred within a ring fracture system centered on Pumice Valley west of the chamber in the last 700,000 years. The monocraters sit atop a 7.5-mile long arc on the eastern side of the 11-mile-wide ring fracture system. Magma feeding the domes may have exploited arc-shaped fissures around an intrusion of granitic rock deep below the chain. This magma chamber is separate from the magma chamber under Long Valley Caldera. The recent eruptions of the monocraters have been similar in volume and nearly identical in composition to those of Glass Mountain that preceded the Long Valley Caldera forming eruption. It has been suggested that the monocraters' volcanism may represent an early stage in the development of a future caldera. Repeated eruption of dacity and rhyodacity from vents on the southwest rim of the caldera from 220,000 to 50,000 years ago formed Mammoth Mountain, a volcano composed of overlapping lava domes. Eruptions of dacity and rhyodacity occurred in Mono Basin from 100,000 to 6,000 years ago. Mono Craters, Negat Island and Black Point. Multiple eruptions of silica-rich rhyolite from 40,000 to 600 years ago built the Mono Craters. Black Point, today on the north shore of Mono Lake, is a flattened volcanic cone of basaltic debris that formed under the surface of a much deeper Mono Lake about 13,300 years ago. During the most recent glacial period, several eruptive episodes from 1,600 to 270 years before present in Mono Lake formed Negat Island. The magma reservoir feeding the Mono Lake volcanic field is unrelated to the Mono Craters magma reservoir. Basaltic andesite lava built the red cones, two small cinder cones 6.2 miles southwest of Mammoth Lakes, around 8,500 before present. The 5 Mammoth mountain craters are a set of explosion pits that trend west-northwest for 1.6 miles near the northern flank of Mammoth Mountain. None of the Mono Craters near the lake show the effects of wave erosion, but a hill at the southern end of the field shows what Israel Russell called a beach line. The present elevation of this beach line is the level of the Mono Lake high stand before the formation of the northern Mono Craters, plus any surface deformation that has happened since that time. Stream-rounded stones are found on the volcanoes, and were lifted up as the volcanoes grew. Although glaciers were present throughout the Sierra Nevada, they did not reach as far down as the Mono Craters. The most recent eruptive episode on the Mono Craters occurred sometime between the years 1325 and 1365. A vertical sheet-like mass of magma, called a dike, caused groundwater to explosively flash to steam, creating a line of vents 4 miles long. A mix of ash and pulverized rock, called tephra, covered about 3,000 square miles of the Mono Lake region. The tephra were carried by the wind and deposited in a layer 8 inches deep 20 miles from the vents and 2 inches deep 50 miles away. Pyroclastic flows of hot clouds of gas, ash and pulverized lava erupted from these vents in narrow tongues that extended up to 5 miles away and covered 38 square miles. Rhyolite lava oozed out of the vents to form several steep-sided domes, including Panum Dome and the much larger North Coulee flow. The youngest domes and coulees are 600 to 700 years old and are, therefore, the youngest mountains in North America. Inyo Craters and Paroa Island. Eruptions of silica-poor rhyolite from 5,000 to 500 years ago created the Inyo Craters. The most recent activity occurred just a few years after the Mono Crater eruptions, and was caused by a dike of similar composition. The dike eventually became 6.8 miles long and up to 33 feet wide. The ground above the dike was significantly cracked and faulted. Explosive eruptions later emanated from 3 separate vents. Pieces of molten and solid rock rejected, small craters were formed, and a tall eruption column rose above the vents. Pumice and ash covered an extensive area downwind, and about 1 inch of tephra was deposited where the town of Mammoth Lakes, California, now sits. A pyroclastic flow from South Dead Man Vent traveled about 3.7 miles. Some of the open pits were filled with thick and slow-moving lava to form the South Dead Man Creek, Glass Creek and Obsidian flow domes. Others, such as the Inyo Crater lakes near Deer Mountain, remained open and were later partially filled with water. Smaller explosion pits on the north side of Mammoth Mountain were also formed at this time. In the past 6,000 years, approximately 0.19 cubic miles of magma has been erupted from the Inyo part of the chain. The last recorded volcanic activity in the chain was at Mono Lake between the years 1720 and 1850. An intrusion of magma below the lake pushed lakebed sediments upward to form Paroa Island. Exposed rhyolite is on the north part of the island, and a group of 7 dacity cinder cones and a lava flow are on the northeastern corner. Steam rose in columns hundreds of feet high from Hot Spring Cove on the island, and the spring water was 150 degrees Fahrenheit when geologist Israel Russell visited the island in the early 1880s. History. Human use. People have used resources on and around the Inyo Craters for centuries. Mono-Paiutes gathered obsidian from the Inyo Craters to make sharp tools and arrow points. Unworked obsidian was carried by the Mono-Paiutes over passes in the Sierra Nevada to trade with other Native American groups. Chips of Inyo obsidian can still be found at many ancient mountain campsites. Gold rush-related boom towns sprang up near Mono Basin in the 19th century to exploit bonanzas. The largest of these, Bodie, was founded in the late 1870s and grew large enough to need a tree mill, which was located at Mono Mills, immediately northeast of Mono Domes. Trees directly around the domes and on the slopes were felled to provide timber for the mill. As part of the California water wars, the Los Angeles Department of Water and Power purchased large tracts of land in the 1930s within Mono Basin and Owens Valley in order to control water rights. Excavation of an 11.5-mile water tunnel under the southern part of the Mono Craters dome complex started in 1934 and was completed in 1941. Tunnel workers had to deal with loose and often water-charged gravels, pockets of carbon dioxide gas and flooding. About 1 man was lost for each mile excavated. Water diverted from its natural outlet in Mono Lake passes through the tunnel on its way to the Los Angeles aqueduct system. The United States Pumice Company, based in Chatsworth, California, has mined the area for pumice since 1941. The company markets the pumice in slabs for use in commercial scouring and in large irregular chunks sold as yard decoration. Exploratory drilling for geothermal power occurred near the Mono Craters on the south shore of Mono Lake in 1971. The wells did not show promising results, so the effort was abandoned. Early impressions. The chain of craters has been the subject of several writers and naturalists. Mark Twain visited Mono Basin in the 1860s and wrote about Mono Lake, but did not mention any of the Inyo Craters except for the lake's 2 volcanic islands. He wrote in Roughing It that the lake was in a lifeless, hideous desert that was the loneliest spot on Earth, little graced with the picturesque. Naturalist John Muir explored the area in 1869. He described the Mono Desert as a country of wonderful contrasts. Hot deserts bounded by snow-laden mountains, cinders and ashes scattered on glacier-polished pavements, frost and fire working together in the making of beauty. In the lake are several volcanic islands, which show that the waters were once mingled with fire. Muir described the Mono Craters as heaps of loose ashes that have never been blessed by either rain or snow. In the spring of 1881 and the fall of 1882, geologist Israel Russell studied the area as a side trip during his field research of Lake Lahontan, a now dry lake that covered much of nearby Nevada during the last glacial period. His quaternary history of the Mono Valley, which included a topographic survey by Willard D. Johnson, was the first thorough scientific description of Mono Lake and its volcanic features. Russell named the Mono Craters and wrote, The attention of everyone who enters Mono Valley is at once attracted by the soft, pleasing colors of these craters as well as by the symmetry and beauty of the forms. They are exceptional features in the scenery of the region, and are rendered all the more striking by the proximity to the angular peaks and rugged outlines of the High Sierra. Protection and monitoring. The creation of Mono Basin National Forest Scenic Area in 1984 stopped any further geothermal prospecting. Mono Basin was the first national scenic area in the United States. It offers more protection than other United States Forest Service lands, surrounds Mono Lake and its two volcanic islands, Black Point, Inyo Crater and much of the northern half of the Mono Craters. Litigation and outreach by the Mono Lake Committee, the National Audubon Society and other conservation groups has helped to slow water diversions from tributaries feeding Mono Lake. A series of earthquakes inside Long Valley Caldera, coincidentally starting 2 weeks after the May 1980 eruption of Mount St. Helens in Washington, alerted geologists to the possibility of renewed volcanic activity in the region. 4 magnitude 6 earthquakes struck the southern margin of Long Valley Caldera in an area that was close to the Mono-Inyo fissure system. The caldera floor had also uplifted by 10 inches in 5 years. Upward movement of magma under the caldera was thought to be the cause of the earthquakes and uplift. Persistent earthquake swarms in 1982 prompted the United States Geological Survey to issue a potential volcanic hazard notice for Long Valley. The same year, permanent monitoring of the area by the Long Valley Observatory started. The hazard notice was lifted in 1984 after USGS scientists concluded that magma had been injected into fissures below Mammoth Mountain but had congealed underground. From 1990 to 1996, 150 acres of trees were killed on Mammoth Mountain by 20% to 95% concentrations of carbon dioxide in the soil. Chemical analysis of the CO2 indicated it was derived from magma. Volcanic hazards. The Long Valley to Mono Lake region is one of 3 areas in California that are in the United States Geological Survey's Volcanic Hazards Program. These areas are in the program because they have been active in the last 2,000 years and have the ability to produce explosive eruptions. About 20 eruptions have occurred on the Mono-Inyo Craters chain at intervals of 250 to 700 years during the past 5,000 years. Seismic soundings and lava composition indicate that these eruptions most likely originated from discrete and small magma bodies. The rate of eruption over the last 1,000 years has increased, with at least 12 eruptions occurring. All eruptions in the past 5,000 years from the Mono-Inyo Craters have expelled less than 0.24 cubic miles of magma. Future eruptions in the area will likely be similar in size to the small to moderate events of the past 5,000 years. There is a 1 in 200 chance per year of an eruption occurring along the chain. An eruption in the foreseeable future is probably more likely along the Mono-Inyo chain than an unrelated eruption inside Long Valley Caldera. Effects. A wide range of effects are expected from future eruptions along the Mono-Inyo Craters. Ash and rock fragments may accumulate to a thickness of 33 feet near an erupting Mono-Inyo vent. Downwind accumulations of tephra may exceed 7.9 inches at a distance of 22 miles and 2.0 inches at 53 miles. Winds in the area tend to blow toward and east and northeasterly direction more than 50% of the time, and toward any easterly direction more than 80% of the time. Grain size and thickness of tephra generally decreases gradually with distance from a vent. Volcanic ash will likely contaminate air routes east of the vent. Severe damage from superheated flows of gas, ash and pulverized rock may occur at least 9.3 miles from an explosive eruption. The amount of damage depends on vent location, topography, and volume of magma erupted. Pyroclastic flows from vents on Mammoth Mountain or other high vent could travel farther by gaining extra momentum from the descent. Valleys along the route will be more impacted than ridges, but flows and surges could overtop some ridges. Eruptions near snowpacks may produce lavas of mud and ash that devastate valleys and watersheds. Steam blast eruptions under a lake could form large waves capable of flooding nearby areas and starting mud flows. Basalt lava flows may extend more than 31 miles from the vent. Dacite and rhyolite lavas produce short, thick flows that rarely extend more than 3.1 miles from the vent. Mound-shaped features called lava domes are often created from these flows. Rock fragments thrown from a growing lava dome may reach 3.1 to 6.2 miles from the dome. A partial collapse of the steep-sided growing dome can send pyroclastic flows outward at least 3.1 miles. Taller domes tend to form larger pyroclastic flows that travel farther.